Friends, carbon monoxide tells you that paper is degrading, but carbon dioxide tells you how far that degradation has gone. If CO is the warning, then CO2 is the history. Most engineers look at CO2 values and say, it's high, but normal. That is one of the most dangerous assumptions in transformer diagnostics, because CO2 alone does not give the answer. The real truth is hidden in the CO2 ratio. In today's Electroverse episode, we decode carbon dioxide, CO2, and the CO-CO2 ratio. Why CO2 is always present in transformers. Difference between healthy aging and accelerated aging. Why high CO2 is not always bad. How the CO1-CO2 ratio reveals insulation, stress severity. What ratio values mean stable aging versus active damage. And how senior engineers estimate remaining insulation life. Stay till the end, because CO2 does not talk about faults. It talks about time.
Welcome to this deep dive into one of the most critical aspects of transformer diagnostics. This episode is not about faults. This episode is about transformer life. Today we are exploring carbon dioxide in dissolved gas analysis, and more importantly, the powerful carbon dioxide to CO ratio that reveals the hidden story of your transformer's insulation aging. When we talk about transformer health, most engineers immediately think about fault gases like acetylene or hydrogen. But there's another gas that tells a completely different story. A story about time, aging, and the gradual degradation that happens in every transformer every single day. That gas is carbon dioxide, or CO2. Carbon dioxide is primarily generated from cellulose insulation aging in transformers. Think of it this way. Every transformer has paper insulation wrapped around its windings. This cellulose-based material, whether it's kraft paper or pressboard, slowly breaks down over time. As it ages, it releases carbon dioxide into the oil. This process is continuous, natural, and inevitable. According to IEC 6599 and IEEE C57.104 standards, carbon dioxide is produced when paper insulation ages slowly and naturally. It's associated with long-term thermal aging, normal oxidation, and continuous service conditions. Unlike fault gases that spike during emergencies, carbon dioxide represents aging history, not sudden damage. Here's what makes carbon dioxide unique in DGA interpretation. Every transformer produces carbon dioxide. A brand new transformer will have low levels, while a 30-year-old unit will show significantly higher concentrations. The question is how much and how it compares with company. Let's look at the standard limits. Normal carbon dioxide condition is typically below 3,800 ppm according to IEC 6599. The caution zone sits between 3,800 and 14,000 ppm. A high aging level for carbon dioxide is considered above 14,000 ppm. But here's the critical insight that separates experienced engineers from beginners. High carbon dioxide alone does not mean immediate danger. It often reflects transformer age. A 40-year-old transformer with 12,000 ppm carbon dioxide might be perfectly normal, while a 5-year-old unit with the same level would be concerning. So senior engineers never stop at carbon dioxide. They immediately calculate the carbon dioxide to CO ratio. This ratio tells us how paper insulation is degrading. This ratio is far more powerful than individual gas values. Let me explain why this ratio is so important. Carbon monoxide, or CO, indicates active damage happening right now. It forms when cellulose insulation is being actively degraded under thermal or electrical stress. Carbon dioxide, on the other hand, represents the cumulative history of aging. When you divide carbon dioxide by CO, you get a ratio that reveals the rate of insulation life reduction. A carbon dioxide to CO ratio greater than 10 suggests normal or slow aging and generally healthy insulation. This is what we want to see. It means the transformer is aging gracefully with minimal active degradation occurring. A ratio between 3 and 10 indicates accelerated aging, possibly due to increased thermal or moisture stress. This is a planning signal, not a panic signal. It tells you that the insulation is degrading faster than normal and you need to investigate the root cause. Maybe the transformer is running hotter than designed or moisture has entered the system. But when the ratio drops below 3, this is serious. A ratio below 3 signifies severe insulation degradation, active paper damage, and a high-risk condition. This means company is rising while carbon dioxide remains relatively stable or rises slowly. The insulation is being actively destroyed. Let me paint a picture of what this looks like in practice. Imagine monitoring a transformer over several months. Initially, you see CO at 50 ppm and carbon dioxide at 800 ppm, giving you a ratio of 16. Everything looks good. 6 months later, CO has risen to 100 ppm, but carbon dioxide has only increased to 900 ppm. Your ratio is now 9, indicating accelerated aging. Another 6 months pass, CO is now at 300 ppm. Carbon dioxide is at 1000 ppm. Your ratio has dropped to 3.3. You're approaching the danger zone. Finally, CO reaches 400 ppm while carbon dioxide stays around 1100 ppm. Your ratio is now 2.7. This is serious. This progression tells a story. The transformer started with normal aging, then something changed. Maybe loading increased, cooling became less effective, or moisture entered the system. The insulation began degrading more rapidly, producing more CO relative to carbon dioxide. But here's the crucial engineering principle. Never interpret carbon dioxide to CO ratio without considering transformer age, loading history, oil temperature, and fall gas background. Context matters. A low ratio in a new transformer is far more dangerous than a low ratio in a very old unit. For instance, a 15-year-old transformer with a ratio of 2.5 might indicate severe problems requiring immediate attention. But a 40-year-old transformer with the same ratio might simply reflect its advanced age, though it still requires careful monitoring and planning for replacement. The engineering interpretation must also consider other factors. What's the transformer's loading history? Has it been running at high capacity? What about oil temperature trends? Are other fault gases present? Is moisture content elevated? All these factors influence how you interpret the carbon dioxide to CO ratio. Let's discuss the practical implications of different ratio ranges. When you see a ratio greater than 10, you can generally relax about immediate insulation concerns, focus on routine maintenance and normal monitoring intervals. The transformer is aging normally. With a ratio between 3 and 10, increase your monitoring frequency. Investigate potential causes of accelerated aging. Check loading patterns, cooling system efficiency, moisture levels, and oil temperature trends. Consider more frequent DGA sampling to track the trend. When the ratio drops below 3, you're in emergency planning mode. This doesn't necessarily mean immediate shutdown, but it does mean immediate investigation and action planning. Increase DGA frequency to monthly or even weekly. Investigate all possible causes of rapid insulation degradation. Consider log reduction if possible. Plan for replacement or major refurbishment. The beauty of the carbon dioxide to CO ratio is that it provides early warning. Unlike waiting for catastrophic fault gases, this ratio gives you months or even years of advance notice about insulation problems. It's a planning tool, not just a diagnostic tool. Carbon dioxide to CO ratio helps you decide timing, not panic. It tells you when to start planning replacement, when to reduce loading, when to investigate cooling systems, and when to consider major maintenance interventions. Here's the hierarchy of gas interpretation that every engineer should understand. CO tells you damage is happening. Carbon dioxide tells you aging has happened. Carbon dioxide to CO tells you how fast life is reducing. This progression from individual gases to ratios represents the evolution from basic DGA to advanced asset management.
Remember, modern transformer management isn't about preventing all aging. That's impossible. It's about understanding the rate of aging and making informed decisions based on that understanding. The carbon dioxide to CO ratio is your window into this process. When you're reviewing DGA reports, don't just read numbers, read the story behind them. Look at trends over time. Compare ratios across similar transformers in your fleet. Consider the operational context. This holistic approach transforms DGA from a simple test into a powerful asset management tool. The carbon dioxide to CO ratio represents one of the most sophisticated aspects of modern DGA interpretation. It bridges the gap between simple fault detection and comprehensive life assessment. Master this ratio and you'll transform how you manage transformer assets, moving from reactive maintenance to predictive asset management. In conclusion, carbon dioxide in DGA isn't just another gas to monitor. Combined with carbon monoxide in the carbon dioxide to CO ratio, it becomes a powerful indicator of insulation health and remaining life. This ratio helps you make informed decisions about transformer management, balancing operational needs with asset preservation. Remember, every transformer tells a story through its gases. The carbon dioxide to CO ratio helps you read that story with the expertise of a seasoned engineer.
So friends, This is the real meaning of carbon dioxide and the CO-CO2 ratio. CO2 is not an alarm gas. CO2 is a background aging gas. CO2 can also be influenced by oil oxidation and service age. Therefore, trend plus ratio must always be considered together. It tells you paper insulation has been aging over years. Thermal stress has accumulated slowly, and the transformer has a memory of its loading history. But the CO-CO2 ratio tells you the condition. Low ratio, angst stable, normal aging. Rising ratio, accelerated insulation damage. High ratio, angst active paper degradation. Remember this golden rule. CO shows. The present CO2 shows the past. CO-CO2 ratio shows the future. When the ratio crosses safe limits, you don't wait for failures, you reassess loading, you plan refurbishment, and you manage remaining life. If this explanation helped you understand transformer life, not just faults, then support. Electroverse. Like this video. It helps real engineering knowledge reach more professionals. Comment below. Have you ever tracked CO-CO2 ratio over years? Subscribe, because Electroverse teaches condition monitoring, not guesswork. This completes our core DGA gas series. Next, we will build a complete DGA decision tree, real case studies, and life assessment logic used by utilities. You've been watching Electroverse, where every spark tells a story. Stay charged, stay safe, and happy.